What's up, hackers? Welcome to TTI Live. My name is Taggart, and tonight we are continuing with our clinic on Docker. This and the previous stream are everything that you need to know to get up and running with Docker. We have so far covered the basics of using Docker images and Docker containers, what they are, and how to get them up and running. And we've gone so far as to talk about Docker Compose, which is a special file format and usage of Docker that allows you to spin up multiple containers at once for a specific application. So for example, if you had a WordPress application that required both a web server running PHP and a database server that had its data separate from the PHP application, you can do that in one move with Docker Compose. So if you're interested in getting started, if this is kind of your first foray into Docker, I encourage you to check out our previous video, which is up in perpetuity on YouTube. I think it's still on Twitch, though. If you're not interested in changing venues, it should still be there. That was last Wednesday. Tonight, we are going to go quite a lot further. We're going to go so far as to deploy a distributed application using Docker in swarm mode. And swarm mode is really going to be the overarching concept that we're going to deal with tonight. So far, what have we done? We've created a virtual machine that hosts our Docker containers. In fact, we've made two, and both of them are now working. We have a Docker manager, which is what we were using all of last stream, and the Docker worker, which we're going to finally start using today in short order. So we've spun up these VMs. They're Ubuntu 2204 VMs, and that's generally what we're going to be using, at least what I'll be using for most of my Linux servers, but any Linux machine will do. Yes, you can run Docker on Windows. I don't recommend it because it is kind of a weird hack, and there are just some weird moving parts to it, whereas it just runs on Linux. Okay, so we're kind of going to jump right in. The last thing that we talked about at the end of last stream was Docker networks, where we're able to create isolated networks that allow our Docker containers that are part of a single application that we bring up with Docker Compose to talk to one another, but don't all have to be connected to the internet. So we have a diagram of something like that right here, where we have the scary internet and we have a service or an application made of three different containers. We've got an Nginx web server, we have a Node.js application that's running on some rando port, and then a MySQL database. So the Node server is going to query MySQL for data. It's going to provide information on some HTTP port, but all of that is getting proxied via Nginx. All three of these containers have to talk to each other, or at least Nginx has to talk to Node, Node has to talk to MySQL. MySQL and Nginx never have to talk, but whatever. The point is that they all have to talk to each other, but only one of them really needs to hit the internet. So what we do is with Docker Compose, this happens under the hood. Docker Compose creates an ad hoc network for all three of these things, allowing them to communicate, and interestingly, allowing them to communicate and reference each other via hostname. It does name resolution for the hostname or the service name that you give these things inside of a Docker Compose file. But the only thing that we need to expose to the host and do port forwarding for is the Nginx web server. This is going to come into play with our project for tonight that is in fact going to use an Nginx web server and reverse proxy, I should say, requests going into some flavor of a Node application inside of it. But before we get there, let's talk about swarm mode and why it is so cool. So for that, we're going to create a new Excalidraw. I'm going to do my best Sal Khan impression tonight. Okay, so let's bring up we'll do two different Docker hosts. Okay. So this is Docker host 1. And this is Docker host 3. No, just kidding, it's 2. I always thought one of the funniest pranks was the idea, not the animal cruelty part, but like letting two pigs loose in a building and putting number 1 on one of them and putting 3 on the second one. Just so that you spend a lot of time looking for number 2. Okay, so we have 2 Docker hosts, and we're going to swarmify them. We're going to initiate swarm mode. When we do that, we have to decide who's boss. So Docker host 1 will say is the swarm manager. Okay? And then we can have as many swarm workers as we like. And they will communicate over a TCP port that is pre-established. So these do have to have some network connectivity. And workers will join the swarm with a token. So eventually we'll see that happen. But they join the swarm. When that happens, we are then able to take this idea that we saw in the compose file before of services and kick it up a notch. Excuse me. So let's take a look at a Docker compose file. Let's head over to PwC resources. Actually, yeah, let's use the MyScript one, the very small one that we made last time. Now let's take a look at this Docker compose file. We have 2 services, right? We have the web service and we have the Alpine service, which is just an Alpine Linux container that we wanted to be able to access to run commands inside of the network so we could demonstrate the Docker networking. That's all that's happening here. Very, very simple. But these services, web and Alpine, when we spin these up, services in swarm mode can have, for one thing, multiple replicas. So once we're in swarm mode, we can add keys like replicas and give it a number if we want 3 instances of that running. And even if you have 1 replica per, in swarm mode, here's the trick, all else being equal, there's no guarantee that all the containers that make up a service will end up running on the same Docker host. So services then span the swarm. They don't necessarily have to have a presence on just one Docker host. So let's visualize that a little bit. Create a container here for a service. And our service spans like this. And then inside of that service, we could have, let's do a different color. Let's do green. Oops. Okay, perfect. So inside of that, we can have, let's call that Nginx. And that lives here. And we could have maybe MySQL living over here. And these are services, right? Now they're, in our case, made of one container only, but they could be made of multiple containers. But it's also possible that we would have maybe, let's say if we replicated Nginx more than once, we could have one of the Nginx containers running on the manager and one running on the worker. It doesn't actually matter because the networking is being handled across the swarm and they're able to communicate as necessary. So you might be wondering, wait a minute. If I've got a web server, right, and it needs to talk to the internet, how does that work? This is one of the things that is happening under the hood with Docker Swarm. Docker Swarm is handling some load balancing and routing for us. So we can have multiple instances of a web server or a web application running, and they can be running on different Swarm nodes. The only IP address that we need to handle for routing purposes is the manager. The manager will receive that handle it, do some load balancing of its own, and send you to whichever replica of the web server you want, or that is next available based on the load balancing scheme. Hey, Kieran, good to see you. So that's the theory. Let's bring up some services first. Before we get to all of this, let's start slowly, and we will begin by initializing our swarm. To do that, we are going to work on our manager, and let's just bring up some IP addresses here. So I'm on 192.168.99. This is 119. And the reason I need that is because when I do docker swarm init, which is the command to create a swarm or enter swarm mode, I have to give it the advertise adder option, and we will give it 192.168.99.119. Okay, we are now in swarm mode, at least on the manager. Now, if I want to join another node to the swarm, I need this swarm token. And you can see that it's communicating over port 2377. So be aware that those have to be available. Now, this is given to us when we do docker swarm init, but if I clear the screen, can I get it back? I absolutely can. If I do docker swarm join token worker, it will give me back that swarm token so this is how you would join a worker to the swarm. Okay, I'm going to leave that alone for just a moment, because even with a single node in my swarm, my Docker instance on the manager has gained some new superpowers. For example, I now have access to the Docker service command. So we've heard about services already, because that's how they are described. Remember, in the Docker compose file, right? This services, right? Where we define web and Alpine here. So we actually have command line access to services. Docker service, we have the ability to create a new service. Inspect ls ps is a little bit interesting here. And then of course, rm scale or update. Okay, so let's think about that now. Let's create a service, and we'll just do Nginx, because why not? We, of course, have the Nginx image ready to go here. So when we do docker service create, what are our command line options? There are quite a few, as a matter of fact. But we begin with the image, and then any commands. Notice that there is also detached mode, like we talked about before. Any environment variables, you can provide all of those on the command line. Any limits on CPU usage if we want, and then of course our published ports, very important. So let's go ahead and do that. Let's do docker service create -p8080, and we'll do Nginx. Okay, now I didn't give it a name, I really should have, but it will create a service name for us. A few things different happened here that we haven't seen before when we just did docker container run, or even docker compose up. We got an ID, but we also are looking for 1 out of 1 tasks, and then we're verifying that everything is looking good. Let's try docker service ls here. It looks a little bit different than docker container ls. Notice that it gave it its own name. I should have given it a name, but that's fine. And you'll notice that it is in replicated mode, and it has 1 out of 1 replicas. Okay. And if I go to Docker Manager, I've got myself a web server. So I know that this is working. Okay, well, if I want to update it, let's say I wanted to increase replicas, I could do that with Docker service scale. And how does that work? Docker service scale. By the way, I can actually do Docker service update to do it as well and just give it replicas equals whatever, but Docker service scale will work for us. So Docker service scale, and then we'll call it Charming Joliot, or Jolio, I'm not really sure. And notice that it tab auto-completed for me. And we'll say, I want 3. Now I have 3 replicas of this container running in my service. It's still one service, but it's 3 replicas. Don't think my camera's focusing because it's dumb and forgets my settings. There we go. Now, if we do Docker service ls, everything mostly looks the same, except we see that it is 3 out of 3 replicas that are up and running. Now, let's take a look at Docker service ps, which is a flavor of command we haven't seen before. I gotta give it the name, Charming Jolio. Aha. So this is a little bit different. It tells us, let me expand this out a little bit. This is the ID of the container. This is the name of the container. And this is the node that it is running on. Okay. If I do Docker container ls, you'll notice that the Docker container IDs are not the same as these IDs. That's fairly important and a little bit counterintuitive. But it is the case. But be aware that we have the names of the individual containers are around our replicated services inside of Docker service ps. So there is a relationship here. This ts8, you can see that there, and 2yk. So you can see how they're kind of mapped by name. Why does this matter? If I wanted to interact with a specific container, that container would have to be running on the Docker node that I'm currently interacting with. Which is why you don't want to be hands-on with these as much as you possibly can. That's really not a good idea. Ooh, a question. So when you replicated the service, it spun up a new Docker instance. It spun up a new Docker container with a service. Nope, same service with randomly generated names. So what it did was it spun up new replicas of the service, each of them a container themselves, all with randomly generated names is correct. And all based, I mean, you can see that there's a method to it. It's the name of the service, the replica number, and then whatever idea. No worries. I just want to be specific about that terminology because it can come back to bite you later when you start, especially if you're mixing up images versus containers versus services. They are all subtly different. So this is all well and good. I want to demonstrate that we are, in fact, dealing with some load balancing here. So to do that, I'm going to enter number 1. We'll make some changes here. So we're going to do sudo docker. Nope. Why am I doing sudo? Don't need to. Docker container exec-it, that container ID, bin bash. And as you might remember from before, we need to apt update and install Vim if we want to make changes to the files within the container. Apt install Vim. Okay. Luckily, it's pretty quick. And then we'll cd to user share nginx HTML, and we'll vim index.html, and we'll just change this h1 to say I'm replica 1. Okay, excellent. Exit out of that. And let's reload this a couple of times. Oh, perfect. Got it in one. So now when I reload this, it says I'm replica 1, but let me go into incognito mode here, private window here, and see if I can get a different result. I've got a 1 out of 3 chance. Vivaldi, buddy, I don't want HTTPS. Okay, perfect. So you can see here that I got Nginx, same address, but I got welcome to Nginx, and this, of course, wasn't cached. And if I reload this a few times, right, I just have kind of a chance of getting replica 1. Same here, really. I mean, this is cached, but same here. So under the hood, Docker Swarm is doing some load balancing for me across these replicas. Think about that carefully. What that means is that you have to have some guarantee that the contents of your containers are the same. It also means if you're doing something complicated like accessing data, that you may have to do some synchronization between that data so that we don't get different results unexpectedly. That's where things like database sharding might come into play, or other kinds of synchronization strategies. I will also say it's an argument for, if you go to a heavy data-driven application, it's an argument for not containerizing, or let me put it this way, not managing your data layer with Docker. So a solid strategy, albeit perhaps rather expensive, is to use Amazon's RDS or something like that in order to store your data and just have your containers connect to that data layer separately, so that your data is where it is. It's got its own storage, it's got its own management, that's fine. And then all of your application code, logic, and maybe the web server that routes it, that is handled by Docker. You can do it all with Docker. It's just a huge pain, especially when you're talking about cross regions and things like that. All right, so that's kind of the easy mode on Swarm. We had a single node in our Swarm doing all this. Let's do Docker service RM charming Joliot, and that will bring all of that down. Now, if we do Docker service PS, there's nothing left, right? If we do Docker container ls, they're all gone. And Docker service, when we do Docker service RM, it blows them all away. Now, let's try this again, but let's try it with a second node. So again, we're going to do Docker Swarm, because we've initialized Swarm. Join token worker, get that worker token. Copy all of this, and then just come down to our worker and fire that whole command off. Now, this is part of the swarm, and you can do that an arbitrary number of times. By the way, you can have more than one worker in a swarm, which is kind of nice, because then you can offload some worker tasks. That can get a little bit tricky. In the swarms that I've deployed, I've really never had need for more than a single worker. Okay, so all of that has happened. Let's bring the service back up. And let's also right away say name Nginx demo. And we can also give it a replicas right from the command line. And we'll give it 3. Okay. If it's the case that not all 3 instances of the service are running, or replicas of the service are running on the worker node, why might it be that it's taking longer for them to spin up? Why might that be true? What might be happening in the background in order to get these services going? Especially if the worker was right out of the box. Okay, it was pulling the Nginx image. If the worker doesn't have the image that you're trying to deploy on it, and it can pull it from the Docker registry, it will do that first and then deploy. So we saw that 1 and 2 were taking a while to fire up. So let's actually do Docker service ps Nginx demo. As I suspected, 2 of the 3 are running on the worker. One of them is on the manager. And what that means is that in order for these 2 to come up, this thing had to go pull the Nginx image because it didn't have it. I did nothing but install Docker on the worker before we started. Nothing at all. But if we go down to the Docker worker now, we'll do Docker container ls. Sure enough, we have 2 containers that have mysteriously appeared on this, even though I ran no commands to make them. And if we do Docker image ls, it has Nginx, even though I did not do that myself on this machine. The swarm did that for me. It's hopefully starting to become clear why this is so useful. And by the way, if you've ever heard about Kubernetes, this is kind of the beginning of what Kubernetes does. Now, Kubernetes does a bunch more stuff, okay? But at its core, container orchestration is what it's all about, and Docker Swarm does that as well. I contend that Docker Swarm does, like, just enough container orchestration so that you can deploy a replicated application, not necessarily at, Google scale, but you can deploy a containerized application that is replicated across multiple nodes, that has some redundancy or high availability, and it allows you to do it in a way that is, at least for me, a little bit more accessible than all of K8's, because it is quite a thing. It's like just enough container to get dangerous. All right. Let's bring the service down. Oh, actually, I should clarify this. If I try to do Docker service ls on the worker, it will still yell at me. Yes, it's in swarm mode, but it's not a manager. And so I can only run that command from swarm managers. Okay? And that has implications for maybe access control. Perhaps you want somebody to have access to a worker, but not to have access to the manager. So there are some things to consider there. Let's go ahead and bring this service down. Docker service rm, Nginx demo. Good night, Nginx demo. But now let's see the same process done with a compose file. So we already have this compose file here. Let's vim the Docker compose file. Okay, so we're going to take this image latest, we'll take the web service and we'll call this replicas 3, and we'll do 2 replicas of Alpine. Why not? Okay. Now we have a different command to use when we do compose files, which is Docker stack. Docker stacks are pretty interesting. Let's actually go get the Docker stack full documentation here. So Docker stack deploy is pretty much what we're going to play with the most. And you can see there that it takes a compose file and you give it a name, and that's kind of it. I want to show you something else. let me actually bring that service back up much more quickly this time. Okay, Docker network ls. Okay, I want you to notice something really important. Do you see how it didn't make a special network the same way that it did with Docker Compose? It didn't have to because of the overlay network that it's using for this communication. However, if I created a specific network, then it would have done so. Let's remove that service again. And this time, we're going to use Docker Stack. Docker Stack deploy compose file, docker compose.yaml, and we'll call it my stack. Additional property replicas is not allowed. Oh, weird. Hold on. Oh, because... Why is that true? What did I do wrong? Oh, deploy replicas. My bad. It should be deploy mode replicated in replicas. So we will fix that. Okay, deploy mode replicated. And we will copy that. And fix that there. Okay. I think I actually want this there. Okay. Let's try it again. There we go. Notice something else. It created a network. When we do Docker Stack, it makes a network, just like if we did Docker Compose. So there's a significant difference between using Docker Stack and using Docker Service. Now, if we do Docker Service ls, check it out. Both Alpine, we have two services, right? We have the my stack, because it creates the service name based on the stack name. Hey, Katie, thank you so much for the follow. It creates the service name based on the stack name and then the service name that we give it in the compose file. Now, if we do Docker service PS, hold on a second. Docker stack. Yeah, we can do Docker stack ls. And that says my stack services too. That's unhelpful. If we do Docker stack PS, I keep forgetting to give it the name of the stack. Now we're seeing a little bit more data. So Docker stack PS my stack. Now we're seeing the service name, where it's running, and you can kind of see if I do Docker Service PS, I have to kind of grab that from here if I'm starting from Docker Stack PS. Okay, but you can see that these do match. So these IDs match up. But of course, I have two things. I've got an Nginx and an Alpine running on my manager, and everything else is running here. Sci-Fi 2142, thank you so much for that follow. Right, so that's Docker Stacks. pause here for questions, because maybe there are some. We've covered a lot already in a short time. The compose file really is the core of doing this stuff at scale, because you're going to define everything that you want inside of that compose file and just use docker stack deploy to make it happen. Docker stack has a couple other options as well. We do docker stack deploy help. Or sorry, let's say I wanted to dynamically change one of the services. So let's say I wanted to change up Alpine to only have a single replica. I can say, even though I did it with stack, I could do docker service scale my stack Alpine equals 1. And that will scale down that specific service, even though I brought it up. Does indentation matter in the compose file, or is it just for readability? No, it super matters, Kieran, in YAML, because YAML is to Python as JavaScript is to, YAML is to Python as, this analogy sucks. White space matters. It's indentation sensitive. JSON, it wouldn't be, because you've got semicolons, commas, not semicolons, but commas and curly braces for delimiting code blocks. But in YAML, you don't. It's all white space, so it absolutely does matter. By the way, you can use docker stack config, compose file, docker compose. You can use that, just like we did docker compose config, to tell you exactly what you're going to do. And if there are any errors, it will yell at you about them. But the config will tell you, this is exactly what you're going to do. This is what we're about to do. Notice that there are things that we didn't put in there, right? The ports, mode, ingress, target, AD, published AD, protocol, TCP. I didn't write that, but that's what's going to happen when we deploy this. Okay, we did the Docker service scale, and now if we do Docker service ls, we can see that Alpine has gone to 1. Okay. Now, there is one other thing that we'll get to, and I just want to kind of preview it here, which is that, let's say I have a new version of an image, and I want to update a running service. How can I do that? First, I would need to pull the new version of the image, make it available, and then I would do docker service update. And let's take a look at that command. Yeah, it's got quite a few options. Docker service update allows us to change running config, including adding environment variables, changing up the image that it's based on, if we want to roll back, quite a lot that's possible here. But it is Docker service update that you would use if you wanted to manually update a running service without bringing everything down. So it's a little bit tricky, but we'll actually see it happen in a moment. What IDE is this? This isn't. This is just a terminal. This is a Terminator. My operating system here is KDE Neon, and the terminal, yeah, it's Terminator, and I'm just using Tmux with a little bit of customization. And the shell is just bash, because these are just servers that I'm connecting to, VMs. Nothing too fancy. Okay, we gained another superpower when we went into swarm mode, and it's probably my favorite one. We got access to Docker secrets. Enjoy that, ASMR crowd. Docker secrets. So one of the things that, if we look at our compose file, we have is this environment variable that is secret 123. This is a bananas bad idea. Don't do this. Do not make your secrets environment variables. Do not commit secrets. Obviously, don't commit secrets to Git repositories. But also, even if you do it inside of a Docker image build, as we covered last time, any environment variable that you add to a Docker image, to say nothing of running containers, but images, those are available through Docker image inspect. And sure enough, it's also true inside of Docker service inspect. We do Docker service ls, right? We do Docker service inspect, and I'll just copy this ID here. So much nonsense. Okay. Environment variables not available at that level, but if we do Docker contain... What the... Alright, I'm starting to get really annoyed at this DHCP issue that I'm chasing down. I figured out how to fix it, but this issue I'm fighting with... the Docker manager, did it change its IP address? Oh, that sucks. No, it's still at... No, it's still at 119. That was close. Okay. What were we doing? We were... Oh, right. We were going to do Docker container ls. Oh, perfect. So if we do a Docker container inspect on this fellow... Actually, it might not be a guy. I don't know. Containers aren't gendered. But at this level, we should have access to environment stuff. Guess not. Although, certainly if we were to attach to it, it would be there. Regardless, we do not want... I know the environment variable is readable. I don't know why it wasn't there, though. Did I get the wrong thing? I totally got the wrong thing. I got the wrong ID. No, I didn't. But I put it in a different service. That would be the problem. Docker container ls. I was losing my mind. Okay, so if we do Docker service ls, let's try the web one. We'll do at this level, Docker service inspect. And there it is. Yeah, I wasn't crazy. At the service level, you have the environment variables that are set as well, which again means you don't want them as plain text environment variables if you actually have secrets that you need inside of your running containers. So how do we solve this problem? Here's how we solve this problem. It's a little bit tricky. You have to pre-make your secrets, which you can script out or whatever, but you have to pre-make your secrets. And if we look at Docker secret, do I have to whisper it every time? If we look at Docker secret, nope, that's too weird. We're not doing that. You have create, inspect, ls, and rm. Be aware though that inspect doesn't give you the plain text secret. Okay, it tells you information about it, but once it's made, you cannot see it except in the containers that you add it to. Let's bring down my stack for a moment, and we'll play with this idea. If we do Docker secret create with a little bit of help, pretty interesting, where you can either echo, you can get it from standard in, right? We can echo it, or you do it from a file. So we'll do it from standard in. So echo password 123 to Docker secret create, and then we have to give it the name of the secret. We'll call it my secret, and then either the file name or whether it's standard in, which would be dash here. Now, command line gurus, tell me, how could I run this command without saving it to my command line history? Base 64, that's just security through obscurity. No, no, no. Redirect history to dev null. That's one way to do it. There's another way. Richie gets it! Adding a space in front of it. If you add a space in front of the command, it does not get entered into history. Yep. Yeah. Echo, I'm in history. Okay, we'll do history. I'm in history. Okay, then we'll do space, echo, I'm not. That's why you pay the big bucks for these courses. Anyway. Yeah. Now, as it turns out, Orbital, thank you so much to that gift to Never Satisfied. Appreciate that. Now, when we go to do this Docker, we echo password 123. When we go to do this to Docker secret create my secret, we're gonna run into a problem. I think. Oh, never mind. I really thought we were. I thought for some reason, even if you add your user to the Docker group, Docker secret create, there's like a file that it can't write. So you'd have to use sudo, but I guess not. Nice one, Karen. Okay, so we just echoed this to history, right? To docker secret create my secret. Now, if we do docker secret ls, there's this thing called my secret, and it has that same ID that we just saw. If we do docker secret inspect my secret, we get some information about when it was created and all of that, but we'll never see the plain text. So how do we deal with these? And once the secret is made, how do we work with these? And by the way, if you're familiar with technologies like HashiCorp Vault, I'm not saying that Docker Secrets is a better tool than those by any means. Or if you have a PAM solution or whatever, like those are fine. But if all you have is Docker, it turns out that it has a secrets manager inside of it, and it's not terrible for this kind of use case. So let's modify the compose file to take advantage of secrets. This requires a couple of steps. So we're going to vim docker compose. Okay. We're going to blow away our environment variable here, but we are going to add a secrets section and give it my secret, and that's an Nginx. We'll take that and we'll add it to the Alpine as well. We're not done though. Here's defined by secrets on a per service basis. Exactly. So this is the short version, where inside of our service we just say secrets and the name of the secret. But then notice this is separate from services. Let me zoom that in a little bit. This is separate from services. We have to define our secrets, and to do so, we either give it a file where we demonstrate, we create it there. Instead, we're going to tell it that it is external true in this case, because we've already made it. So all the way up at the top, secrets, my secret, external true. Okay, we're going to do docker stack config compose file docker compose.yaml. I made no mistakes, shockingly. And so we are then once again going to do docker stack deploy compose file docker compose my stack. Okay, we're once again creating the network, we're creating the services. And everything looks like we're good. We do docker stack ps every time. Docker stack ps my stack. Everything's up and running. And who's running here? Doesn't really matter which one. I'll take one of the webs. Okay. Docker container ls. Okay. Perfect. Let's use the Nginx because it has bash. So we're going to attach to it. We're going to do docker container or exec. We're going to do docker container exec -it. By the way, who remembers what the T stands for? Super Taggart. Good job, chef. It's actually short for TTY, so terminal is part of it, but the pseudo TTY, a pseudo teletype terminal. And if you want to know what that is, because you're all babies now, this is a teletype terminal. Before we had cathode ray tube displays, if you wanted to connect to a mainframe computer, you used one of these. And the output from the computer was literally printed out on paper. Exactly like this. And your input was printed on paper. This is where so many of the metaphors of our interfaces comes from. Scrolling. It's a scroll of paper. It's rolled, right? You can scroll up and down. All of this comes from this original interface. Oh no, so chef, when I say super user do, I say sudo, which is correct. But in this case, I was saying pseudo, like false TTY. And that's why I was getting tripped up. It is, in fact, when we talk about TTYs in modern computers, they're, in fact, pseudo or false TTYs. Like pseudopods have fake legs, right? Anyway, teletype terminals. This is where it all began. Exactly, PTY. Thank you. That's really what a sudo is for. TTY is straight up teletype. Okay. History lesson over. We are now inside the Docker container. And let's do ls var run. Oh, hey, look. Secrets. ls var run secrets. Wait, what? Yeah, so the way this works is that your secrets are mounted as files inside of containers that have the secret. There it is. This is the only way that you can see the secret. And it's also how your containers can access it. Everything is a file. Well, in this case, for sure. But this is how your containers access secrets. Now, I want you to think critically for a moment. I swear you typed the secret with capital letters here earlier. No, not the secret. When I did the environment variable, it was with capital letters, but not the secret. So think critically. If these things are files, what might be some kind... What kind of a thing might we usefully mount as secrets inside of running containers? What types of things could be crazy handy to mount as secrets? So credentials, obviously, right? If we had username, password. I'm thinking of specific file kind of thing that it turns out this is wonderfully useful for. Although I suppose this is kind of a credential. What if I had an Nginx server that was going to provide HTTPS traffic, SSL traffic. But what if I wanted to, or in fact needed to, manage the certificate outside of the container? Yes, I can mount, and especially for distributing that certificate to my multiple replicas of the Nginx server, I can distribute that certificate using Docker secrets. That thing's going to be looking for a file anyway, and so I can create the certificate, the private key and the cert, and mount them as secrets inside of the container. Then my web server has access to them. That is the basic idea, and it's one of my favorite things to do with Docker secrets. It makes that particular process very, very simple. All right, let's exit out of this container here. And Docker stack rm my stack. Down you go. So I don't have anything here set up as a signing authority. So we'll fudge it a little bit. That's okay. I'm going to go get myself a fake cert. I love this thing, by the way. I know that everybody at one point in their home lab or sysadmin journey, if you do Linux stuff, is going to run OpenSSL commands to create a self-signed cert. And that's fine. But here's the thing. It's a huge pain. And you don't have to. This site, I found, will just make self-signed certs for you that you can just use. Very, very easy. So we'll call it Docker Manager. It doesn't really matter. Generate SSL. And then I have myself a cert and a private key. I just run HTTP and live on the edge. Even with a... So certbot I love, you know, but I only ever use it for Let's Encrypt. Okay, so we'll save docker manager.cert. And we'll save the key. And so let me exit out of my SSH section for a moment. We'll scp downloads docker manager.cert to seclab at docker manager. Cool. And docker manager dot what key? Private key. Cool. Fantastic. We'll reconnect to the manager. Okay. Confirm I have my certain key there. Fantastic. All right, we're going to modify a few things. Actually going to move Docker Manager into the My Script folder. Nope, I think it's time for a new thing. So we're going to make dir my app. And then we'll mv the Docker star, Docker Manager star into my app. Okay. Lovely. Now, there's one other thing that we need to make, and I'm sure it's everybody's favorite thing to do, which is writing an Nginx config. What we're going to do is we're actually going to make a new service with the Nginx config, or a new image. And this gets interesting. Because when you cannot pull the image directly from a Docker registry, the workers don't know what to do, basically. So you have a couple of options for that. We'll talk about how that looks in just a second. Okay, let's start with a nginx config. So we're going to vim nginx.conf. Okay. Server. I'm going to cheat a little. Oh yeah, hold on. It's HTTP first. But before that, it is events. Events. And good lord. Set TS equals 4. Set ship with 4. Thank you. Much better. Okay. Worker connections. 768 is fine. It's standard. This is stuff that you don't need to know to do Docker. It's just Nginx nerdery. But if you want to create a custom web server, maybe we'll do an Nginx thing one night where we do a deep dive on Nginx, because I use it more often than you might think to do all sorts of different things. Right? Nginx isn't just a web server. It's going to serve for us right now, or sorry, not right now, in the next thing we do, as a reverse proxy, which is how I use it all the time. And it's also going to it can also be used as a load balancer. So lots of cool stuff you can do. We'll do the SSL certificate right here. And this is all the way up at the top. So SSL certificate. Var run secrets. And we'll do my cert. And SSL certificate key is going to be var run secrets my key. Okay. Other stuff. gzip on. And then we'll do the HTTP redirect. So we'll do a server block. Listen on 80. And server name Docker manager. And then we'll return. Return 301 HTTPS Docker. Just straight up host. And request URI. I don't have this memorized. I'm looking at a configuration that I've used in the past. I just want to be clear. You don't have to memorize this. It would be bananas to do it. I mean, even if you write Nginx configs frequently, there are so many directives. But this one we're going to do listen 443 SSL. Okay. Server name Docker manager. Okay. And we already did the SSL certificate. Now you can put it in here if you wanted, and maybe that's a little bit cleaner. And we need a root, which is user share nginx HTML and index.html. I think that's enough to get a basic thing going. Just let ChatGPT write your Nginx configs. I will not! I invested too much time learning how to do these. Okay, no lie though. I had ChatGPT write me a Terraform plan the other day. And like half of the things that it put in there didn't exist. It just isn't ready for prime time. Okay, I think that looks good. So then we have to create a Docker file. So we're going to do vim Docker file. And we'll do from nginx latest. Right? We're going to copy nginx.conf to etc nginx.conf. And we'll do copy, we'll give it an index.html to user share nginx html index.html. And I don't think you have to redo the expose anymore, but we'll do expose 80. Or no, expose 443. Let me make sure I got that right. So we'll do Docker file. Expose is the directive to publish ports. I just want to make sure that I have that right. Yep. Expose 80. What is it? No comma? No comma. Phenomenal. Okay. So, we can either, in our Docker Compose file, we can either use a pre-built image, or it can be built here in the Compose file. Let's start our Docker Compose.yaml. So version 3.9, services. In this case, we'll just do web. The image, in this case, we'll do a build. And the context is here, and the Docker file is default, which if we look at our Compose file spec, we have the ability to do this inside of image. File build. Yeah, like that. So there's actually a short version too. And if we want to give it a tag, we give it a tag name. So actually, we'll just do image my app, and then we'll build here, and we'll do ports 80 to 80 and 443 to 443. Okay. Now, of course, we're not done because we have secrets. My cert and my key. Now, in this case, we can do secrets, my cert, file, thank you. And my key. File. Okay, let's use docker stack config, compose file, .compose. It's not yelling at me, which again, nuts. I never expect to get these right. But actually, we go back up to secrets just to confirm. Secrets. Service certificate. Now see how they did external true. Secrets top level element. Yeah, file. Okay, we did get it right. Perfect. All right, let's give this a shot. Docker stack deploy. Oh, what did I forget? I forgot something very important in our Docker compose file. Right, which is to do mode replicated. Right, just like so. We'll just grab this and put that right there. Okay, we'll do docker stack deploy. Compose file, docker compose, my app. What just happened? We created the network, we created the secrets, except now we have a problem. Because I think the secret names will be wrong. Let's do docker service ls, and let's do some docker service logs. Logs, very important that you can do logs. Okay. Notice that none of them are up. Docker container ls. Yeah, something went wrong. So let's do docker stack rm. Oh, actually, docker image ls. Did it build? It did not. which is interesting. This file. Let me go to the build real quick. Make sure this is good. Okay, I wasn't crazy. It does require a context. Okay. Now let's do docker stack config again. Post file. Yeah, we'll see if this actually gets fixed. It should. We'll do docker stack deploy, compose file. Oh, every time. My app. Ignoring unsupported option build. Oh, crazy. So you can't, I'm sorry, I forgot that part. You can't build for Docker stacks. That's fine. Let's fix that then. And that actually works fine for what I want to do next anyway. Okay, great. So now we need to build the Docker image that we want to use, right? We do Docker image build, and this is a review from last time. We'll call it my app, my app latest. And we're going to build it right here because that's where the Docker file is. Oh. Forgot the /. Let's try that again. Hey, Casper. Let's calculate checksum index.html. What's it yelling at me about? Oh, God. Oh. That was very silly. I forgot to make index.html. There we go. Okay. There we go. So, nginx.conf got copied over. Index.html, now that it exists, got copied over. Fantastic. Now, we're going to try docker stack deploy, compose file, compose my app. No, Casper, we are doing the clinic on using Docker, and we're in part 2. If you want to check out part 1, where we started from installing Docker all the way through basic Docker concepts, you can check it out here on Twitch. It's 2 streams ago, or you can check it out on YouTube. Okay, now let's try this one more time. Okay, Docker service ls. Still nothing. Docker container. Okay, so they're coming up. And then they're going down again. So there's something wrong. So we're going to do Docker service logs to see if we can get anything from the service. Okay. No SSL certificate is defined for the listen SSL directive in etc nginx nginx conf. Server name var secrets. Something has gone wrong here. Yeah, I forgot a semicolon is what went wrong there. Okay, so we're going to... We actually can fix this a pretty interesting way. We're going to do another Docker image build. And then we're going to do a Docker service update force and my app web will then... Ooh, something still went wrong. Huh? Nope, we've got 2 up. Docker service PS. Okay. If we look at the things that are shutting down, some of these are running, and some of these are shut down. If we look at the ones that are shut down, look at the error, no such image, right? Oh, now all 3 are up. That's kind of cool. Because it tried to deploy them to the worker, but the worker didn't have the right image. There are a couple of ways we could have solved that problem. Let's bring it down. Docker stack rm my app. We're going to just bring the whole thing down again. How can we solve the problem that the worker doesn't have the image that it needs to bring up our special version of Nginx? How can we solve that? If this were something that we were publishing to the web, or a container registry, we could just have it pull it down, which is what we saw at the very beginning of this when it did do that for Nginx. But for the moment, we're not sending that up. We could change that up a little bit, and I'll show you how to do that in a bit. But there is a way to just get the image and then sneakernet or just SCP from one place to another. Here's how we do that. Docker image save has the ability to take images and save them out. And so the way that that will work is we're going to save my app.latest or my app latest, and we're going to save that to myapp.tar.gz. That's what comes out of Docker image save. This takes a second because we're outputting some data. I was wondering where that sound effect came from. Yep, it's missed. Okay, now if we look at that, we have myapp.tar.gz. So we're going to just send to 120. These two can talk to each other. So we're going to do SCP Cyclab at my app. Or so Cyclab at. Good. Over you go. Okay. Now on the worker, if we do Docker image load, it loads an archive from a tar archiver standard in. So we'll do Docker image load my app. tar.gz. And now we have the Docker image over here. No registry required. We were able to just send it from one place to another. Now, if we do Docker stack deploy one more time, compose file, docker compose.yaml. One of these days, I'll actually add the app name. Okay. Docker service ls. It's coming up. Docker service ps. Nope, it's never going to happen. And we're up. Notice that 2 of them are on the manager and 1 of them was on the worker. Let's see if all of this worked as I hope. So I can actually just redirect here. I got redirected to HTTPS. Now, it's an unsafe cert, but nevertheless, if I look at it, there's my Docker Manager cert. It is, in fact, redirecting. This is Docker Swarm Cheeto, yes. So we'll head there. We'll proceed. My app is loaded. So I have this working in Docker Swarm mode. We built the image that it was relying on, and then we used the Docker Compose file to deploy it. Now, what if I didn't want to have to move images manually? And, in fact, what if I didn't want to have to build that Nginx image manually? What if I didn't want to do that? How could I do that? For that, we have to exit our nice, comfortable home lab and actually deal with the cold, brutal, bitter, brutish internet. We're going to use 2 things. We're going to use GitHub, and we're going to use the Docker Hub. Now, for what I'm about to do, I don't think that you can use what I'm about to do on a free tier for the Docker Hub. Maybe you can. Well, we're not going to do Git from the command line too much, so don't worry about that, Katie. We're just going to use GitHub, and what we're going to do is connect a Git repository to a, sorry, both hands should be in frame for this, a Git repository to the Docker Hub. And what happens is when we push to a specific branch in GitHub, the Docker Hub is going to take a look at that and say, oh, okay, the Git repository has a Docker file. Docker Hub will build the new version of the image based on that Docker file, making it available to anything that uses it. So we'll have a few pieces working together here. Okay. Now, as I said, I don't know if this works on a free tier. I'm really not sure. Let's find out. I pay for Docker Hub because I use this service pretty frequently, and it's not crazy. It's like $7 a month. Maybe it's not that anymore, and my price is just grandfathered in or something. Oh no, I'm paying too much. It's $5 per month. Hey, what's the big idea? No, I wanted to know 200 image pulls per 6 hours. I wanted to know if you could do automatic builds, and I don't think so. Because I'm not seeing any builds here. It's the auto builds that I'm talking about. So we'll start on GitHub, though. Okay. Some fun things here, actually, that are about to happen. But we'll start on GitHub. Isn't it GitHub Actions that initiates the build and pushes to Docker Hub? Nope. You can do it that way, but you don't have to. We're going to do it in the Docker-centric way. Requires no API keys or anything. So I have this Docker demo repo already built. And so basically what I'm going to do is I'm going to take the files from my app here and put them into this repo, which I've helpfully already cloned onto my workstation here. So I'm just going to scp our seclab at Docker manager, my app here. I actually didn't need the image. You made me mess with Rust. I didn't make you do anything, but if I inspired you, Katie, then I'm delighted. I hope you had a great time, or you at least learned something. I don't know if anybody has a great time the first time they use Rust. Everybody falls the first time. Oh, I'm glad you liked the Offensive Con presentation. That was the presentation equivalent of firing off several fireworks in sequence in a show. And they all worked. Okay. So, now we have a problem, which is that I need these secrets, right? But I need to not have them in GitHub. I can't have my private key going to GitHub. Even if it's a private repo, it's a really, really bad idea. So I'm going to separate my concerns a little bit. And rather than generate my secrets in Docker Compose here, I'm going to do that from files that are separate. So I'm going to vim the Docker Compose here and change this basically. And make it external true in both cases. The reason I want to do that is because I just don't want those certificates actually submitted to GitHub. So I'm going to remove the Docker manager stuff from here, and those will live only on my manager. And in fact, for that reason, if I do docker secret ls, you'll see I have the secrets still, but I'm gonna knock them off. So I'm gonna do docker secret rm my app my cert. Oh, docker stack rm my app, Spring app down the app. That would be why it was there. Docker secret ls. It should be gone now. There we go. Okay, so I'm going to just simply docker secret create my cert Docker manager.cert. Okay. And then my key, Docker manager private key dot key. Okay. So I have those secrets available to me in the swarm, but they're not going to touch GitHub because I don't want anybody else to happen upon my certificate. Okay. But what I do want is everything else. The Docker file in particular. And then Docker Compose is fine, but we're going to actually modify the Docker Compose a little bit because the image is no longer going to be my app. In fact, it's going to be my Docker Hub username / the name of the image. So in this case, it's going to be taggerttech / Docker demo. That's the name of the image. And in order, I mean, it'll be public, so that's fine. You all can play with this if you want. That's totally fine. It'll be public. But if it weren't public, if it were a private repo, I would have to run Docker login in both of my, or all of my nodes in order to gain access to the images so I could pull them. You enter your Docker Hub username and password or access tokens if you want to do it that way, and then you're solid. And access tokens would be how you do it programmatically. I've already done that. You can git ignore those secrets, or is there a better method to hide? So I can git ignore them, Katie, but the fact is I don't need them in the repository anyway. And so that's kind of why they're there. Okay, I'm gonna MV my app. Yeah, they're only, because they're only going to live on the server where they're, or the swarm where they're being used, I have no need to even git ignore them. They're just not going to be present in the Git repo at all, right? They're not going to be in the folder so that I don't run the risk of making a mistake with them. Okay. So this is going to seem a little bit wacky. From our nodes perspective, I'm actually going to do something that seems alarming. I'm going to rf my app. Because it's no longer my app. We're doing something else now. And then here I've got the Docker file. Whoa! Mayor Joe, good to see you. Thanks so much for those 5 gift subs, friend. And hey, I am excited for your upcoming Python C2 stuff. That looks really neat. So we're going to just git add basically all the things here. Git status. I'm going to say git commit m. It works. Or add all the things. These are not good commit messages. By the way, I have a Git course coming up. I'm hoping to have it done. Well, definitely before the end of April. Git push. Okay. And so I've set that up. Everything looks good. All because you wanted to understand more about sockets. I totally get that. Okay, so everything's good here. If I reload, this is good. Now comes the fun part. We're gonna set up an auto build in Docker Hub. So I'm gonna create a repository here. This is a Docker image repository, not a Git repository. They are different things. Docker demo. It's public. And now, here's the auto build. So we're going to click on GitHub here, and just me. There's Docker demo. Hey, look at that. Okay, and so the source is, they need to change this. It's branch main, not master. And the Docker tag is going to be latest. The Docker file is the Docker file. We could change that if we needed to. And we are going to then create and build. What happens now is the build will take over. It's on its way. Come on. Build is in the queue. I don't like waiting. I hate waiting. But once this builds, and it will be a quick build because it's such a small Docker file, then we will have this available to pull. And it, rather than have the my app in our swarm, in fact, we're going to do something a little bit different. We're going to git clone github.com/empty/docker demo. It's public, so I don't need to be logged in or anything. We're going to cd to Docker demo. Now, let me pause there. Even though I'm about to auto build the image, and even though I technically had all of that stuff available to me, why did I just clone the Git repo down into the swarm? What do I want from the Git repo in the swarm as the build succeeds in the background? Can you run Nginx with 250 megs of RAM and 100 megs of disk? You can, depending on what you're doing with it. I wouldn't recommend it, but you could. No takers? Why did I need the Git repo? This is why I needed the Git repo. This version of the Docker Compose file has the right image name. And so when I do the proper secret configuration. So now when I do the Docker stack deploy from this Compose file, what should happen is it's going to go pull this image, which does not exist on either the manager or the worker node right now, because my app is not the same as taggart tag/docker demo tag latest, which, as you can see, built successfully, and I now have it. You can go check this out right now. And so let's try docker stack deploy compose file, Docker Compose, from the Docker demo Git repo that we just cloned. Unbelievable. I'm 0 for like 100 here for adding the actual stack name. Okay, now when we did docker stack deploy, hey, look, it pulled this. And it replicated this. I didn't tell it to do that, by the way. It just did it. And by the way, why was it so dang fast to pull down this image? Why was it so fast? Oh, hey, look, it's on the worker too. I got 2 on the worker and 1 on the manager. I want some critical thinking. Somebody take an educated guess why the Docker image pull from a brand new image that I'd never seen before was so quick. I mean, that was quick even for 100 some megs. Or was it 100 some megs? I'll give you a hint. It has something to do with this. MRigger has it correct. Same layers as some other image. Most of it was based on Nginx, which we already had, on both the manager and the worker. And because most of it was based on Nginx, remember that Docker images are layers of changes. And so, because most of the layers were exactly the same as layers it already had, it didn't need to pull anything but that last layer, which was our changes, these copies right here. That was it. So I want to be clear. We had most of the parts of the image. Let's see if we can see that a little bit more clearly. We do Docker image inspect Nginx. Okay. So it only pulled the difference, exactly. Trying to see what the easiest way to do this is. D container config. Config. Make sure graph driver, redfs, layers. Okay, let's take a look at these layers here. Okay. And actually, I'll do this down at the bottom. Docker image inspect. Okay. Look at the layers. There were 3 additional layers in ours. 1, 2, 3. Those were the additional changes. And because most of the rest was already present, we only had to pull the difference. So MRigger has it correct. Think of each line in a Docker file taking a snapshot of the file system we already had, the from layer. So yeah, this was all that was remaining. That concept is really misunderstood by a lot of folks, but it's important to understand. And it's why it can be difficult to understand how Docker uses space, right? And how builds actually happen. And in fact, when we do a rebuild So interestingly, like if we do a rebuild, if we were to make a change here, Docker would say, okay, all but the last layer is the same, which means I can start from this layer, whatever that layer's hash is. I can start there, and then we can move forward and keep building from there. You can force a total rebuild, but often you don't have to. You just start from the things that have changed. Huh. Let's quickly recap what has taken place, because quite a bit has. We started by initializing a Docker swarm with Docker swarm init. We then joined the worker to it with the Docker swarm join with the join token. We were then able to create Docker secrets that allowed us to create secrets that we put inside of running containers. We talked about Docker services. Services being replicated instances of running images, also known as containers, that can be distributed across members of a swarm. They don't have to be on a single node in a swarm. Then we used Docker Stack to define multiple services and deploy them the same way that we did with Docker Compose, except Docker Stacks can go across members of the swarm. And finally, we automated the build of a Docker image with a Docker file pushed to GitHub. So let's do one last thing. Let's show a rebuild. Okay. I will do git commit -am, add subheader, git push. Off it goes. Let's see what happens now. Wow. Took no time at all for the Docker Hub to recognize that there was a push to my GitHub repo and discover, oh, I need to do a rebuild. In dev, you wouldn't do this. Instead, you'd mount a host folder into an image. Yeah, I really don't like doing that. And by the way, Mrigger, that's tricky in a swarm, because you can mount a host folder, but you can't do that across the entire swarm. You could only do that in a specific node. So if you were developing and you were developing on a swarm that was across multiple nodes, you would have to use a different storage layer to make that happen. You'd dev and compose swarm is overkill for dev. I don't agree. If you are developing for a distributed application, like for like isn't the worst idea. So it can be smaller, but still testing how your distributed stuff works is I think valuable. Or perhaps you would call that your test rather than dev, right? Maybe dev in compose, but then test in a swarm. Especially if you're developing for something pretty rarefied, like if you're using S3 storage or other sorts of cloud storage layers rather than basic file system storage. So, okay, the build is finished. It should report success in a moment. And this will have changed the hash of the latest tag, which means when we do a Docker image pull on this image, a new version will be made available. Now, this part's a little tricky. All right, so we have a new version here. I'm going to go over to our swarm. I'm going to do Docker image pull Taggart Tech Docker demo. Okay, so we saw already exists, pull complete. Okay, now I'm going to do Docker service update. And I usually do force for this. Docker demo web. Okay, so it's producing these tasks. Docker image ls. Notice that the worker still has an image that was from 13 minutes ago. This can lead to some complications. Okay. You can see that I'm still getting the old version even though I had the new image. And interestingly, only one of my images is running on the manager. So I have a 2 out of 3 chance of hitting the older version of the app, right? So that's problematic. I need to make sure that all the nodes have the latest version of the image. Now we're going to do another update. By the way, there is no Docker stack update. It's per service. Oh, man. Now I'm just curious why I'm not seeing the new version. This can be a problem. Yeah. So for this, we're going to just Docker stack rm and then bring everything back up. Docker stack deploy, compose file, Docker compose, Docker demo. So this is actually a gotcha that kind of drives me crazy. And there is a solution that's a little bit better than what we're doing here, which is to use a tool called Watchtower. There are other solutions, but I find Watchtower to be an elegant solution for this. What does Watchtower do? Watchtower is a container, but it runs with the host's Docker sock, var run docker.sock, inside of it. What that means is that it's a Docker container that can run Docker, and also when it makes changes, it's making changes to your host's Docker process, which is kind of wild. But that is, in fact, what it does. The other thing that it does is, because it's accessing the docker.sock, it is looking at running containers, the images that they're based on, and then every 15 minutes or so, it will poll for new versions of the image, pull the new image, bring down the container and keep the existing config and bring the new container back up. Is nesting like this okay? It's fine for this, but there can be some concerns. If you are allowing access to this container for one reason or another, that can be scary. So there are some security concerns, absolutely. Anything that has access to this docker.sock could, like, if somebody got access to this container, they functionally have access to the entirety of your file system, right? If you don't have any other safeguards set in. Just as we saw in our first stream, you could do a privilege escalation that way. So you want to be careful with that. There we go. Now we have our new version of the image updated. Okay. Well, friends, I've actually completed the planned curriculum for our 2-part intro to Docker. We have gone as far as I really think is necessary for our intro. Now, MRigger says an advanced feature for a future class: push statics to some S3 Gluster CDN so that live containers don't break when half the swarm serves old CSS.js. Yeah, that is an advanced feature. And a couple of other things that are outside of the scope. One thing I didn't want to do is play with advanced Docker volume drivers. So you can create some pretty cool different kinds of Docker volumes that use S3 storage and are available across a Docker swarm, so that you can have a single place for all of your containers to store things. We didn't do that, but those are also things that you can do. But just to get you started with Docker Swarm, get you comfortable with distributed services like this, I think this is where we want to stop for now. So thank you so much for hanging out. I really hope you learned something tonight. We had a lot to do, but we got through it. This is one of those that may reward rewatching, so definitely don't forget about that, and consider checking it out on YouTube. Also, if you are liking what we're doing here, consider checking out our courses at the Taggart Institute. And honestly, the best way to say thanks is to consider purchasing one of those courses. They're all free, but they're also pay what you wish at $5, $10, or for the advanced courses, $15 tiers. And it would be kind of cool for you to show your appreciation that way. I'm terrible at selling these things, but I'll just put that out there. If you're interested in what we've been doing here and you would like to support it, that would be the best way. Better even than Twitch subs. So I think we're going to call it a night. We have a few other InfoSec streamers that are on right now from the hack list. I think we're going to give Cerberus a raid. So we'll set that up, and I will be back on Saturday. I have some plans for API hacking. So we're going to get back to our roots, doing some web stuff, but in the API realm. So I will see you then. Until then, friends, please be good to yourselves, be good to each other, and happy hacking. I'll see you next time.